Live. Hi folks, and welcome to Open Analysis Live. So today we have a Twitch clip for you where we're taking a look at an unknown binary, and we're going to walk through some of our own triaging process. And hopefully along the way we'll give you some tips on when you should be looking at the sample through static analysis, when you should really be reverse engineering a sample, versus when you should just be running it in a sandbox or in an unpacking service.
UNPACME.
To get more context about what's going on or unpack it. So that's really the goal of the stream, is to save you guys a bit of time with a couple tips on what you should be looking out for in a binary to try and figure out, is it packed, is it junk, should I be looking at it, versus should I run in a sandbox or do I need to reverse engineer it? And of course, if you enjoy this clip, we have a full catalog of streams on our Patreon. You can go check that out, along with in-depth reverse engineering tutorials. So without further ado, let's get into it. So let's download the sample, and then we will kind of recreate the scenario that led to this, and then we can talk about how to avoid this. So where's our download button here? There's our download. We have the sample here, and let's open it up in IDA. Oh, that's not good. Whoa. All right, there we go. Graph is too big. All right. Okay, so this is where we stop. This is the first place we stop. So what have we done? Not wrong, but what have we done that we could have avoided to save us some time? Well, we opened this thing up in IDA. So usually when we're triaging an unknown sample, by we I just mean me and Sean. There's only two of us at UNPACME. What we'll do is we'll look at it in a sandbox first. Right? You want to look at it in the sandbox because you want to get an understanding of what the hell it's doing and whether it's worth opening in IDA or not. Let's say you didn't do that though. Let's say you open it in IDA and you're trying to analyze it, and you see something like this. What's the first thing that you're going to think? Well, the first thing that I think is that something's fucked with the binary, right? This doesn't look right. So there's really only two things that could happen where one function is too large for IDA to display. So either A, it's obfuscated somehow, right? There's some sort of obfuscation. Or B, it's packed, right? So token knows what's up. So there's really only two, there's no third option there. Either you're dealing with something that's obfuscated or you're dealing with something that's packed, which is in a sense obfuscated. So that's the first hint. Anytime you see this, those are the only two options. I'm sure there's some big brain out there who's gonna be like, well, actually there's a third option. Usually there's not. Usually it's just one of the two. So already you've narrowed down your choices from, this is a sample I want to look at, but it's obfuscated, so I'm going to need to do some work. Or this is a packed sample, abort, get the fuck out of here and unpack it first, right? Two decisions. All right. So let's take a little bit of a look at what they're doing here. Or I programmed it, everything is main and no function usage at all. I mean, that's a form of obfuscation, though. We're going to assume that that's a form of obfuscation. Yeah. Okay, so let's, you can see this, a bazillion locals. All right, yeah, this is what I want to show you guys. Look at these API calls and ask yourself, do I know what get system metrics is? I don't know what that is. I assume it gets some metrics from the system. I'm gonna Google it. What does it do? Retrieves system metrics or system configuration settings. Interesting. What's the parameter? You send it an int, and what does it give you back? Maybe some sort of struct or something? What does it give you back here? Return value is an int. Interesting. Is the requested value system metric value. Okay, cool. So you can send it all these different ints, which are mapped to different pieces of information you want to pull from the system. And here, let me make this smaller so we can flip back and forth easily. Okay, so you pass it one of these integers, which is mapped to a piece of information, and then the return value will be that piece of information. All right, let's see how they use it here. So they push this value as an argument, and they call get system metrics. Well, so that's how it works, right? IDA is telling you that's the index, right? So this is the value, and Do we have that value? That seems like a pretty high value. Is that all the values? The values go up to what, like 86? Oh, here's a high one. Let's maybe turn that into a hex value. Is that something that we see here? Is that a valid option? What are you saying there? Very zen. Is it two? Is it like an ORD? Two sets of two information? Can you send two pieces of information? I don't know if you can do that. This parameter can be one of the following values. So you can't do that actually. X varies X. You can't do that. So this value has to match exactly one of these values. And if we do a search here, it doesn't. So what does this tell you? Immediately, what does this tell you? It's an invalid argument. You're sending an invalid argument, right? You're sending it a value that is not, it's not in the table, right? You're sending it something that doesn't exist. X varies X. Try search in headers. So you suspect that this value is valid, but it's just not listed in the MSDN docs, but it would be listed in the headers because it's somehow hidden. Is that what you're suggesting? That's a good suggestion, by the way. So I don't see this input value in this list here. I think it's an invalid value. In the back of my mind, VarisX is telling me that maybe it's a hidden value. That's possible. That's definitely possible. We need to contend with that. But what we can do is we can go a little bit further and we can say, all right, they're passing that value to get system metrics. The return value from get system metrics is the value that you're getting, the metric that you're getting. So why don't we look at what they're doing with the return value? So that's going to be an RAX. So what do they do with RAX? Or I guess, sorry, EAX, because it's NX64, or x86. So it's 32-bit, so it's EAX. So return value is an EAX. What do they do with EAX? Well, they don't do anything. They call another API right afterwards. So if you're not convinced that this is garbage beforehand, you should definitely be convinced now, because not only are they sending a value to it that is probably invalid. It might be in the headers, it might be hidden value, but it looks like it's invalid at first glance. They're also not checking the return. They're just calling that API for shits and giggles. They just call it.
What?
Called it. Why? Why have they done this? Right? So this now should tell you something very important about this sample. They're making junk calls to APIs. They're calling APIs with values that are possibly invalid, but they're certainly not checking the return from those API calls. So that means that this code right here is garbage, is junk code, right? Now, anytime you start seeing junk code in a sample you have taken the time to open in IDA, you need to stop and reevaluate what's going on, because you could be wasting time. And that's really the crux of this stream, right? Is don't waste your time. So if you see something like this, you need to kind of reevaluate what's going on here. Why am I seeing junk code? Now, if we didn't know that, if we didn't know enough to stop, after we look at the second the second API call, you should really start to get some alarm bells going. You can see the two parameters that they passed to find window A is just it's gobbledygook, right? And I think that was actually I think that was the oh yeah, right, yeah, don't worry, Ida, I'm not gonna make you show us the graph view. I think this was actually the question that I saw in Discord, was somebody was asking why would find window have these giant strings being passed to it? Now that's a valid question if you were to only look at this. So if you were to like copy paste that into a Discord chat and be like, why is find window A looking for a window name with this weird base 64 looking string and a class name of this? Well, the answers are either A, there's some specific window that has that name that it's looking for some reason, or B, it's junk. So you can't really tell. But if you were to paste this code into the Discord, you could tell, right? Because you could say, okay, well, this is a junk call, so it's a good chance this is a junk call as well, right? Now, when you have a bunch of junk like this, again, it's probably in your best interest to stop what you're doing and reevaluate. Now, personally, what I like to do is not even open IDA. I like to run it dynamically in a sandbox that has no sandbox tells, so that you can just see what the hell is going on. And thankfully, or hopefully, Malware Bazaar will have done this for us. So this is why I suggest looking at Malware Bazaar first. Also, entropy will say a lot if it's a packer. Yeah, you could check entropy. Yeah, that's a good suggestion. I don't ever check entropy. I don't even know how to. So that's why I don't. I use these other methods, which I'll show you today. But you can check entropy. I know many people have had lots of success with that. Yeah, I don't. I mean, if you look at UNPACME, we have it listed, but like, I don't know. There's better metrics. Oh yeah. Also, I don't have a heavy drug habit. It's just allergies here. I'm sorry, guys. My nose is really stuffed up. It's like pollen season. Okay, so we know that there's some junk code in here, and we're gonna want to figure out why is there junk code? Is it because they're trying to obfuscate something, or is it because it's a packer stub and the whole thing is garbage, right? There's only two options. So if it was obfuscated, I would expect that somewhere in here, look at all this junk. I would expect that somewhere in here I might see some non-obfuscated code, some code that actually does something. But this is not the right way to do it, to scroll through it. That's not useful, unless you're looking at the matrix like Neo. It's going to be hard to find stuff here. Yeah, or they're bad at programming. I mean, that's always a possibility. So we could scroll through it, but that's not what I would advise. Instead, what I advise, yeah, it's masochism, exactly. Instead, what I advise is take a look at some dynamic options and just see what they tell you. So let's take a look at these samples and or these sandboxes and see how they perform for our sample. So the ones that I actually like quite a bit, I like any run, and for each one of these I'll explain why I like them. I like any run because there's almost nothing in the sandbox. It's kind of like just running it on bare metal, and the reason why that's important is you can usually check the results from any run versus running it in your own VM. And if it runs in any run and not in your VM, then you know there's something wrong with your VM. There's some sort of detection that it's figured out. So that's why I like any run. But it's not my first place to go. It's usually my first place to go if I suspect there's something wrong with the VM. Cape Sandbox, I love. That's usually what I use. Let's take a look at Cape. It's open source. And it has, most importantly, APIs, which are the most important part of a sandbox. Sandboxes today have kind of morphed into all kinds of different higher level concepts. If you look at Joe Sandbox, it's basically like a malware oracle, right? It's morphed into something else. Same with Triage, it's kind of like Sandbox Plus. But unfortunately, a lot of them don't have these API lists. Joe Sandbox does, which is nice. But yeah, I like Cape, and I also just like that it's open source, so I enjoy recommending it. So what we can do in Cape is we can start looking at the API calls, and the nice thing about this is these are going to match up what you would see in a trace in your look at all this crap. This is going to match up what you would see in a trace if you traced it in your debugger. Only instead of in your debugger where you're going to have to look up each call and get the arguments from the stack, this just does it for you. So it's just a nice, it's kind of like having a trace from your debugger, but it's in a nice format where you can look at the arguments and stuff. They can also tell you like whether the call failed based on the response code and stuff like that. It's just nice to to look at. Obviously, they don't trace every API call. There's a subset of APIs, but usually it's enough to figure out what the heck is going on. Oh, guys, you're in for a treat. You're in for a treat. There we go. Yeah, so let's take a look at this this trace here and try and get a little bit more information about what this sample is actually doing. And again, I do apologize for those of you in the chat who had the answer an hour ago. Again, this is just to show you a provable, repeatable process that you can use to understand should you waste time in IDA or not. So here we can see our famous, oh yeah, this, I should also mention this. At the beginning, when you load a sample, you click on an exe, and then the Windows loader does some shit, and then it transfers execution to the entry point of the PE file. That's how, that's how anytime you run an exe, that's how it works, right? Well, the loader does some shit is actually also just a whole bunch of API calls. So after a while, you're going to get used to this, but if you haven't seen this before, at the beginning of a process, if you're tracing the process, you're going to see a lot of stuff like this, which you can pretty much ignore. Usually this stuff has to do with the loader, loading up the PE file. You're going to see things like imports and stuff like that. Now, sometimes it's important to pay attention to this, so I don't have a generic suggestion for, when to pay attention to this and when not to. But what I can suggest is in the binary itself, we're at the entry point here. Remember this, or not the entry point, sorry, the main function here, where it was too large to display. And we know that in the main function here, so we're in our main here, this is where the main code is. And we know that right after all the setup is done for the function, we're going to jump to main. And we can see here these get system metrics and find window A calls are like the first things, as we just saw. So my suggestion for making sense of the API trace is just scroll down until you see one of those APIs that makes sense. And then you can localize yourself in the code. So you know that when you see this hit, you are most likely right here in the code while it's executing. You could also do things like matching up the caller. If you know the base address, you can match up the caller with the APIs and try and figure out where you are in the binary. But you don't really need to do that. You can just rely on the fact that this is a pretty unique API call, and likely this is, we're right at the beginning of the start right here. Now we can already see, like I mentioned before, these are the two arguments, right, that are passed. And you see, that's not what you would expect for a class name and a window name, right? So you already suspect something is dickered here, something's wrong. And like I said, you've already done your little analysis in IDA, and you've determined that they are passing junk arguments to some API calls. So 10 to 1, this probably is a junk API call, and you can see they're just calling it again and again and again and again, and just hammering it, right? I think someone in the Discord had a name for this, where you just hammer on an API to try and f with AV. I can't remember the name for it, but they had a name. I didn't know that there was actually a name for it in the industry. I think it was called like API hammering or something. Anyway, if you guys know what that, whoever said that in the Discord, I thought that was an interesting piece of information. I didn't realize that was actually a term that people used. What's the point of hammering an API? So it is API hammering? Yeah. What's the point of it? Well, I guess there's 2 points. One is you're generating a lot of noise, right? So it looks like the binary is doing something. It maybe makes it look a little bit more legitimate. If you're doing static analysis, so you don't know what these APIs are, this code will fill out the stub if it's a packer and make it look more legitimate. But also, API hammering can be used to mess with sandboxes and antivirus that doesn't handle APIs very well. So if there's a look back in the sandbox, or like a limit to how many APIs it can track, or in AV there's like a look back limit, so you can only track a window of so many APIs. API hammering can be used to basically fill up that buffer And then when you get to APIs that actually matter for your malware, there's no more buffer left for the AV or the sandbox. Now, nowadays, this kind of thing doesn't really, it's not going to do very much in terms of that. Most AVs it doesn't matter for them. It's not going to do anything. And most sandboxes, if they're set up right, again, they should have the capacity to deal with this. So it's more of a legacy thing, but it might, it might help in some cases for anti-detection. But also you have to keep in mind for static analysis, it's very difficult to determine that this code, it's easy for a human to look at this and be like, this is junk code, but it's hard for a machine to look at this and tell that it's junk code. So this looks like a bunch of legitimate code, not legitimate, but a bunch of code that's going to run, but of course it does nothing. So it's a good way to pad out your binary, if that makes any sense. After they do a bunch of this stuff, they also allocate some memory. Not a whole bunch of memory, but a little bit. So that might be interesting. That's a potential interesting thing to look at. So now we know if we wanted to, we could use our debugger and we could trace anti-allocate virtual memory, and we could look at what's actually being populated in these segments. You can see they're consecutive, right? So that's interesting. We could do that. Let's continue on here. ND-set information process. That's that's interesting. That might be useful at some point. What else we got here? Oh, we got more junk code here. Right? So whatever they were doing here, it might be something interesting to look at. We don't really have too much of a clue of what was going on here. Right console, that looks like some more junk code maybe. Possibly not, I'm not sure. But we can see after that little break, we get back into this find window bullshit. So let's continue on. Oh, look, there's a lot more. All right. Interspersed with all of this junk, what's this? That looks interesting, right? You've got a virtual protect, execute read write. That's a dangerous section to have. Anytime you see this, and it's malware, almost certainly this means they're injecting code, right? Execute read write, that's probably injected code. So where are they actually injecting this code? Here. I don't recognize that address. Not really sure. I wasn't tracking where they allocated the memory earlier. So anyway, this is telling us this is probably going to be injected code. By itself, this API call virtual protect, where you change the protections to execute read write, isn't necessarily a red flag. But if you've already determined that it's malware and you have junk code in it, and you see an API call like this, I mean, that's three strikes, right? So almost certainly there's going to be some injected code here. Now we have our find window here. More obfuscation, tons and tons of it. Jeez Louise, tons. Oh, here we go. All right. So now we've gotten to something that is not the find window stuff. We create a process, app launch. And what's important about how they launch it? Well, they launch it suspended. So those of you who have seen our older videos, or those of you who have done a lot of unpacking manually, we already have 3 strikes. Well, this is the home run here. So if you have obfuscated code, you have sections being, the protection of memory sections being changed to read, write, execute, and later on you have create user process that's creating the process suspended, or create process internal, creating it suspended. That's definitely like process injection 101. And then we see the trifecta afterwards. Created suspended. They get the context thread, so this is where you can change EIP. Actually, we made a whole video on on the context thread and what that was. Read process memory, allocate some memory. Oh, look, there's a mem copy. They're copying some memory in. Write process memory, what are they writing in? MZ, blah, 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 blah. So they're writing a PE file into the created suspended process, resume thread. Okay. So why did I go through that so quickly? Because if this set of API calls, create process internal, get context thread, allocate virtual memory, write process memory, virtual protect, well, this is not necessarily always virtual protect, but then set context thread, resume thread. If that API set is not burned into your brain by now, you need to go back and watch all of the OALabs catalog of process injection, because these, actually I think it might be, yeah, I think this is process hollowing. This set of APIs, anytime you see that, that should be ringing alarm bells that this is Packer, and it has unpacked something and injected it into applaunched.exe, right? So this has been me blabbing a lot, so it was kind of slow going. But if we go back, we zoom out to the original problem that we're trying to solve, which is I opened this file in IDA. I noticed that there, first of all, the function is too large to display in IDA. There's too many nodes in the graph, so it's huge. Second, they're passing arguments to API calls that don't make sense, and they're not checking the returns from the API calls. Third, I go to a sandbox and I notice that they're just hammering these APIs again and again, which I already know are fake. Then I see the trifecta of API calls, which means process injection. What do we have? We have a Packer, right? So this whole process should take you no more than maybe 10 minutes, maybe a bit longer if I just slow loading the binary up. But there's no need to question any further what's going on in IDA. As soon as you see something that looks fishy, you need to get yourself over to a sandbox and look at the API trace and see what's going on. When you look at the API trace, you're not always going to get easy answers, right? You need to understand what these APIs are doing, but this is pretty outrageous, right? This is not normal, right? This is not a normal way to do things. So you see you're smashing this API.
You're gonna smash everybody.
And then after you smash it a bit, you create a process suspended and then inject into it, change the context thread and resume thread. So that's in a nutshell, that's how you should be triaging these samples. As soon as you see something that doesn't make sense statically, if you're not getting anywhere, you're seeing API calls you don't understand, you must Google the API calls, figure out what the arguments are. Do the arguments make sense? Did they use the return value from the API calls? If none of that is adding up, take a look in a sandbox and see what does it do? What does the sample actually do? Okay, so that hopefully answers a lot of these questions that I've been seeing on Discord, and that will kind of bring us up to the next state of analysis, which is, what do we do now? We know it's packed sample. What's the next steps?
UNPACME, a malware unpacking service from Open Analysis. Expose the malware before it exposes you.
All right, I hope you guys enjoyed that, and I hope it's useful for you. And of course, big shill for our Patreon. Go check it out if you like this kind of stuff. See you next time, and remember, keep exposing the mechanics behind the malware. Stay curious.